Well, good afternoon, everyone. We're going to pick up with our notes on section 9.1, which was solving systems by substitution today. So yesterday we started out by looking at what it graphically means to solve a system of equations. We started with two lines, and we looked at graphing them by hand once we put them into y-intercepts. So we started with this initial. We found that intersection, and then you can see the graph here. I showed you how to enter that into your calculator. And then to get the output and find the intersection. So again, that's a tool that we use to double check our answers, not to cheat through, because ultimately these processes that we need to be able to do by hand, we will eventually be solving three variable systems, and things just continue to get more and more complex. So taken away from yesterday, we should have seen that it's an intersection, okay? And I closed with yesterday saying that if we had parallel lines, those would never intersect. And so that would be an example of no solution. And if you ever graph the same line where that line is on top of another one, that is what would represent an infinite number of solutions. Once we moved past example 1, we looked at example 2. And this was just a very simple, not a lot of coefficients on the front of these two equations, and then we went through the process in solving. Again, I want to emphasize that whenever you write your solutions, they are ordered pairs, which means that they are coordinates. So you can see the final stuff that I circled down here in green. That is how your answer should be presented. It should be presented as an ordered pair or a coordinate. Now today what we're going to look at is a couple more examples of things that are just slightly more complex. I know this has been several times I've taught this, so it's usually the same types of questions that come up. Now we're going to move on to solving one with substitution that has one small difference between it. So let's look at example 3. The directions solve the system by substitution. In the system that we're going to be presented is 1/5 x plus 1/2 y is equal to 8. And the second equation is going to be x plus y is equal to 20. Now the first thing that should jump out at you on this particular equation is that we have fractions. So you can solve this without getting rid of the fractions and it'll work just fine. But I want to remind you on this problem that we can always clear the denominators. Before we get to clearing denominators, let's go ahead and isolate y in the second equation. So I'm going to rewrite the first equation, unchanged at this point because this is our notes. And the second equation, I'm just going to subtract x from both sides. That gives me y is equal to 20 minus x. Now, don't write this down in your notes, but again, right now we could take, since y is equal to 20 minus x, we could insert that where we see y. Remember, we would be using the distributive property and distributing the 1/2. I'm going to choose to not do that, and instead what I'm going to do is multiply and clear the fractions in the first equation. Looking at the denominators 5 and 2, we know that the least common multiple of those are 10. So if we multiply the entire equation by 10, then that will still be a true statement, or the same exact equation. So if I multiply that by 10, we end up with 2x plus 5y is equal to 80. Don't forget to multiply your constant. And then we're just going to copy the second equation, y equals 20 minus x. Now we're ready to go to work. Okay? Remember, because y is equal to 20 minus x, it can be inserted into the other equation. Make sure you use the distributive property correctly. Rewriting that tells us that 2x plus 5 times the quantity, 20 minus x, is equal to 80. At this point, we just have some algebra. Using the distributive property, combining like terms, And now we just simplify that. So yes, it's a fraction. Sometimes they work out that way. It's not the end of the world. So it turns out that x is going to be equal to, this is actually positive 6 2/3, but we're just going to leave it as 20/3. Now we're not done. We need to go back up into the original equation, and we need to solve for y now. I mean, use common sense. Use the easiest equation possible. The easiest one in this course is going to be to go to this equation. And I typically just draw 2 arrows, and so this is where I'm going to pick up. So I essentially have y equals 20 minus x, and since x has been found to be 20/3, I know that y is equal to, now be careful when you enter this in your calculator. So if I'm looking at 20 minus 20 divided by 3, and the parentheses aren't necessary, but it's nice to remind us that it's a fraction. And then we're going to turn that into an improper fraction, and it tells us that 40/3 is what y is equal to. We bring these two ideas together, and we write our final answer as an ordered pair: 20/3, 40/3. So the reason that I chose this problem is because the answers aren't always going to be pretty. Notice that I could not write this answer as a decimal. It has a denominator of 3, which means that it is a repeating, non-terminating decimal. The best way always is to write your answer exactly. And most often in this class, that's going to be an improper fraction. Let's take a look at one final example. In this final example, we're going to use our graphing calculator to double check it in the end. So it'll be another place to practice that. But in this course, or in this particular example, we're not going to be dealing with 2 lines. Instead, we're going to have a curve and a line. So example 4. Directions, solve via substitution. And our system is going to be x squared plus 4x minus 7, minus y is equal to 7. Our second equation is 2x minus y is equal to -1. So solving this, now since I've already told you we don't have 2 lines, you may remember this from Algebra 1. This first equation is actually a parabola. Okay? Parabolas in general look like this. They either open up like that or they're going to open down. And the width of them will change as well as the location in the coordinate plane. But they always look the same. It's a quadratic equation or a parabola. The second one is a line. So it turns out that we could have several solutions for this one. We could actually have 0, 1, or 2, which we will further investigate once we solve this. But let's just go through the analytical or the algebraic approach. The key here is looking at the second equation. Clearly the easiest variable to isolate is going to be the y. So I'm going to do that. We'll start out by just rewriting the first equation unchanged. Now isolating y, that will give us y is equal to 2x plus 1. Now we're ready for our substitution. You just have to be careful with all of your algebra and distributing the negatives. We're going to take this 2x plus 1 and we're going to insert it for y. Notice the subtraction sign in front of the y. That means that we're going to be distributing a negative once we get this thing going. So our new equation gives us this: x squared plus 4x minus the quantity. This is where our substitution goes. So I'm looking at this right here. That value is going to be, or y is going to be replaced with the quantity 2x plus 1. And then that is equal to 7. Slide up here a little bit. Let's go and use the distributive property, combine like terms. So now we have this equation. Notice that it's not easily solved with the methods that we had before, because this is a quadratic. Now refer back. This, about a month ago we learned or refreshed on how to factor. This is a type 1 trinomial. It's type 1 because that lead coefficient of 1. The method for solving this is we're looking for factors of our C term, which is -8. And the factors of 8 are pretty basic. We just got 1 and 8 and 2 and 4. And the only way you're going to get a -8 is if one of those numbers are negative. Now, how do we know what combination to use? Well, they need to add to give us +2. So what we're looking at is +4 and -2. So that tells us that this factors into x plus 4 times x minus 2, and that's equal to 0. Now we fall back on an idea called the zero product property. The zero product property simply states this. If I'm thinking of two numbers, and I tell you that when I multiply them it's equal to 0, you can tell me that at least one of my numbers must be equal to 0. We're going to use that to solve this equation. So we know that either x plus 4 is equal to 0 or x minus 2 is equal to 0. Quickly solving these tells us that x is -4 or x is +2. And these are keepers. Notice that at this point we have two different solutions, or we're going to have two different coordinates. Now, we're going to take this equation, we're going to plug it back into our original system to find out what the corresponding y value will be. Clearly we want to use the second equation, which you can see peeking out on the screen. So I'm going to plug it in right up here, and that equation is going to yield. So we have y is equal to 2 times the quantity plus 1. We insert the value of 2, and that tells us that the corresponding y value must be equal to 5. Hang on to that. Notice I'm keeping my things lined up, or my coordinates or my values lined up vertically. I again do the exact same thing. Okay? And so I know for when I had an x of -4, we still used the same equation, 2 times the quantity plus 1. If I insert -4 into that, then y turns out to be -7. We're essentially done, except that at this point we want to write our final answer as an ordered pair. And there are two solutions. Okay? A solution to the system is -4, -7. Or you could use the solution 2, 5. And there you go, ladies and gentlemen. There are the two solutions to that system of equations. Now what I'd like to do now is to show you how this is going to work in your graphing calculator. So in order to do that, we are going to need to have y isolated in both equations. It's okay on the second equation, but we've got to isolate the other one. So let's just go ahead and rewrite them over here on the right hand side. So if we isolate y in the first equation, that's going to give us y is equal to x squared plus 4x minus 7. And we already had it isolated in the second, and that was 2x plus 1. Let's go ahead and get our graphing calculators out, ladies and gentlemen. So what we want to do is go into your y equals. I know that for some of you this is entirely new, or you just saw it the other day. But remember your variable, so you're going to type x squared plus 4x minus 7. Go down to the next one, and I'm looking at 2x plus 1. There we go, my calculator locked up for a second. 2x plus 1. Now you want to make sure you're in a standard window. So if you aren't, the easiest way to do it is to zoom standard, which is option 6 here. And we get a graph that looks kind of like that. So notice that we have a parabola. The parabola is the blue one on my screen, and then we have the line. So generally, we had two answers, and since our coordinates were -4, -7, and 2 comma 5. Notice that those are the corresponding. I'm going to go through and I'll show you one more time how to find that first intersection point. Let's go after this one here that's positive. So you're going to go to calculate, okay, which is second trace, and you're going to go down to, go figure, intersection, and hit enter. And just like we did yesterday, it's going to ask you 3 questions. It's going to ask you to select the first curve. I'm already highlighted on the first curve. Then it asks you to make sure that you're using the second equation, which I am, and then it asks for a guess. Now this guess is really important when you have more than one particular intersection point, because you want it to find the one that you're visually going after. I want the one up here on the right, so I want to get my cursor close to that so it knows to go after that one and not the other one. And you notice that our solutions that we did by hand, 2 comma 5, they match up with what the graphing calculator does. So there you go, there's the technology side of it. Now one last look at some of these concepts. I want you to generally realize, hey, we've got a parabola. There are several different scenarios that we could have. You know, is it possible to have no solution? Absolutely. If I had a line that did not intersect that parabola, then there would be no solution to the system of equations. If I had a line that just nipped the parabola at one location, okay, we call that tangent to the parabola, then there would just be one solution to that system of equations. And then you have the third possibility, which is where our line is secant to the curve, in which you would have 2 solutions to that system of equations. All right, homework for tonight. Now we're going to do 2 days of homework. Tonight, this is your homework. So from section 9.1, I would like for you to do tonight number 1, 2, 5, 6, 7, and 9. For tomorrow, during class, I'm going to give you time to work on 21 through 27 odd, and you're going to do 47, 49, 51, 63, and 67. So these are your homework problems. Again, 2 days of problems. And on Friday, I will begin teaching the next section, which is solving by the elimination method.